So, hello everyone. In this lecture, we would be discussing the first 10 problems of IBSL 2020 Chemistry Paper 1. So, let's start with the first question. So, in this question, we were asked the molar mass of a compound if 0.2 moles of the compound has a mass of 13.2 grams. So, we know that to calculate the number of moles, we have to divide the given weight by the molar weight of the compound. So molar weight is basically given weight by number of moles. So given weight here is 13.2 and number of moles is 0.2. So upon simplification, it comes out to be as 66 grams per mole. That is option B. Now in this next question, we need to find out the number of carbon atoms in 12 grams of ethanoic acid. So firstly, we need to find the moles of ethanoic acid. So NCH3COOH, this would be our given mass divided by the molar mass. That is basically 1 by 5. Okay, so we know that in 1 mole ethanoic acid, 2 moles of carbon are present. Okay, so in 1 by 5 moles of ethanoic acid, total moles of carbon would be like 2 times 1 by 5, that is 2 by 5. That's basically 0.4. Now hence, total number of carbon atoms would be this moles of carbons times the Avogadro number, that is 6 into 23. So this finally comes out to be as 2.4 times 10 to the power 23, and correct answer is option D. Now in this third question, we need to identify which of these molecular formula are also empirical formula. So for a molecular formula to be an empirical formula, the ratio of the molecules should be in the simplest form. Okay, that means that you cannot reduce this ratio further. So for this first option, this ratio is 2:6:1. And this is a simple whole number ratio, so option 1 is an empirical formula. Second one, option 2, the ratio is 2:4:2, but this ratio can be reduced to 1:2:1. The second one is not an empirical formula, but it's a molecular formula. For the third one, the ratio is 5:12. Again, we cannot reduce 5:12, so third one is also an empirical formula. So our answer is option B. Okay, so moving on to question 4. Which volume of ethane gas will produce 40 centimeter cubes of carbon dioxide gas when mixed with 40 centimeter cubes of oxygen gas? To solve this question, we have to adopt an analogy that 1 centimeter cube volume is basically 1 mole. Okay, in the question we are given that moles of carbon dioxide is 40, moles of oxygen is basically 140. Now let's check how much oxygen is required to produce 40 centimeter cube of CO2. So NO2 required or reacted is basically CO2. Okay, 7 by 4 times 40, that is 70 moles. So basically out of this 140 centimeter cube or 140 moles, only 40 moles of O2 has reacted. So O2 is the excess reagent. Now as O2 is the excess reagent, obviously ethane would be the limiting reagent. So let's calculate the moles of ethane. So as the ratio is 2:4, the moles of ethane would be 2 divided by 4 of moles of CO2. That is 2 by 4 times 40, that is 20. So moles of ethane that would be produced would be 40. So therefore I can say that volume of ethane would be 20 centimeter cube. So option B is the correct answer. So moving on to question 5, we have to calculate the relative atomic mass of an element with this mass spectrum. So this thing is really easy. We have derived a general formula, that is relative atomic mass is summation of mass times percentage abundance divided by 100. We have three masses here, so there would be three summations. The first one, mass is 24 times abundance is approximately 80, I can say. Second one, mass is 25 and the abundance is here, that is 10. So it's 25 times 10. And for the third one, the mass is 26 and again it's approximately 10, the abundance. So on calculating this, what we get is, what we get is 24.3. So option B is the correct answer to question 5. Now let's move on to question 6. So question 6 asks us, what is the maximum number of electrons that can occupy the fourth main energy level in an atom? So this is a very straightforward question. The total number of electrons in any energy level can be determined by the formula 2n squared, where n is the energy level. So here in this question, n is equal to 4, as given it's the fourth main energy level. So 2 into 4 squared, that is 2 times 16, that is 32. For question 6, our answer is option D. Now in question 7, we are asked that which of the following shows us a general increase across period 3 from sodium to chlorine. So we are moving from left to right across a periodic table. So while moving from left to right, any radius, the ionic or atomic radius, both of them decrease due to increase in the nuclear charge. Okay, so option A and B won't be the answers, of course. So option C, ionization energy. As we move from left to right, what happens is, as the nuclear charge increases and the distance between the electrons from the nucleus doesn't increase, so what happens exactly is that it becomes difficult for it becomes difficult to remove the electron. As a result, the ionization energy increases. So for question 7, it's option C that's correct. So now for question 8, it asks that which of the following oxide will dissolve in water to give the lowest pH. So when P4O10 dissolves in water, what happens is it basically reacts and it forms H3PO4, which is a phosphoric acid. Now to balance this reaction, let's balance the phosphorus first, and obviously we'll put a 6 here. So here an acid is produced. Okay, second one is SiO2. SiO2 does not dissolve in water. Next is Al2O3. Al2O3 again is insoluble in water. And lastly, MgO. When we add MgO with water, what happens is it produces MgOH whole twice, which is a base. Now between an acid and a base, obviously acid has a lower pH. So obviously question 8, option A is the correct answer to this question. Now in question 9, we have to identify which of these formula is correct. Now basically we have two parts. So we have NH4 plus and PO4 3 minus. Okay, we know that PO4 3 minus comes from H3PO4 and NH4 plus is NH3 plus H plus ion. Okay, so obviously we would need 3 NH4 plus ions to neutralize this minus 3 charge on PO4. So NH4 whole thrice PO4 is the correct answer, that is option C. Now moving on to our last question. In this question we need to identify which molecule is polar. So here we have a lot of options. So let's identify the non-polar molecules. So CH4, CF4 and CCl4, these two are non-polar in nature. Okay, because we know that any molecule of type AB4 would be non-polar and there is no lone pair on carbon 2. So as a result, these would be non-polar. Okay, also you can think about the symmetry, okay, and all the dipole moments cancelling. Now let's draw the structures of CHF3 and CClF3. So this is the first one. This is the second one. So polarity can also be defined by dipole moment. Any molecule having more dipole moment would be more polar. So here in this case, fluorine atoms are more electronegative than carbon, so dipole moments would be directed towards them. From hydrogen and carbon, carbon is more electronegative than hydrogen. So as a result, you can see that none of the dipole moments gets cancelled and dipole moments get added up in the downward direction. Okay, but for this setup, fluorine is more electronegative than carbon, of course, but chlorine is also more electronegative than carbon. Even for this process too, the net dipole moments would be downwards, but there would be a little bit of cancellation due to this chlorine atom. So as a result, CHF3 will be more polar.